Hello everyone, welcome to this video. In this video, we will try to learn about AI agent and how AI agent works. This video is specially made for the beginners who want to learn about AI agents or multi-agents. So this slide, I have tried to cover all the points which everyone should know. He is learning about AI agents or multi-agents. So AI agents are like a normal employee who is working for an company. So think of a AI agent like a digital employee. So it receive a task and how to do and then complete the task by its own. So no hand holding is required. So if we talk about ChatGPT, so ChatGPT answer questions and write content autonomously. And if I talk about AI coding agent, that read your code and spot bugs and suggested fixes. Uh, and then if we talk about this support bot, so it handle customer question 24 by 7 without human help. What is multi-agent system? So imagine a company where every employee have a specific role. Now replace the employee with AI. That's a multi-agent system. Each agent does one job really well and together they track complex tasks faster like a normal employee do in a company. For example, manager agent assign task and coordinate the team. Then research agent gather fact and data from the web. Writer agent turn research into polished content. And then the reviewer agent check quality before delivery, right? Why using multi-agent? So one agent is like one employee trying to do everything. So you cannot run a company with one employee who will do all the tasks for you. So that's why multi-agent work in parallel, like an employee work in any company, each specialist making the whole system faster, smarter, and more reliable. So when you are doing uh, parallel task with multi-agents, it will improve the speed and each agent master its own domain. Scalability, it add more agent as workload grow. So you can create more and more agents when it is required. So each agent have their own uh, job to do. Now, if we talk about architectures, so for multi-agent, we have three architecture. One is centralized, one is decentralized, and one is hybrid architecture. Now, we will talk about this centralized architecture first. So in this centralized architecture, there is a controller agents who act like a school principal. So it give instruction to all the other agent and make sure everyone follow the same plan. If you see here, it is the centralized agent. It assign task to each agent and each agent will complete their own job. So this is the controller agent. It will send task to the support agent and data agent and writing agent. So each agent have their own role. But the advantage of this is easy to control and monitor and debug. But in case if the main controller is failed, and then it will become bottleneck because no one will be the, able to pass the new task to other agents. This is best for customer support workflow and simple automation. And now we will talk about decentralized architecture. In this architecture, there is no boss and no controller. Agents talk directly to each other like friends planning or group trips, where everyone pitch in and make decision together. So the advantage of this is it's highly scalable and no single failure point. The disadvantage is coordination is harder and debugging gets complex. It's best for robotic, autonomous vehicle and blockchain AI. So if you see in this, this is how work. We have multiple agents. So each agent can talk to each other and pass the information with each other. So agent A is doing data peer routing. So if you see like this agent is sending and receiving data from agent A and same also from agent D, also from agent B. So this is called decentralized approach. It's mostly you can say like the way Bitcoin work in decentralized architecture. This is the same way it's working, right? So that's why this architecture is used for blockchain AI. Now we will talk about hybrid architecture, the best for both worlds. Some agents have supervisor, other work independently, like a company where manager guide team, but each team make its own day-to-day decision. So if you see it's here we have top level orchestrator. You can take this as a CEO of the organization who give instruction to the sub agents, peer to peer agent, and then these sub agent could be like project manager, and they give instruction to own team. So this project manager, you can take an example project manager 1, this is project manager 2 who is giving instruction to other agents. So these agent will give output to this agent, this will give to this agent, and these both will give the output to the top level orchestrator. The advantage is it's flexible, scalable, and highly reliable under load. But the disadvantage is more complex to design and maintain. But this is best for enterprise AI, research assistance, and large scale automations. Now we can do the comparison if you are not sure which architecture to use when. So this side by side breakdown make the choice simple. You can start simple with centralized for straightforward workflow, for simple automations, and you can go with decentralized for large scale systems where you have a distributed system, and for enterprise level where you want scale up the you can go with the hybrid for complex enterprise grade AI. Now we will talk about the, just give me a minute please. Now we will talk about the real world multi-agent AI in actions. So most of the companies are already using multi-agent for AI coding assistant, and for customer support, and for the research agents, and for so many tasks people are already using multi-agent system. Now we will in this slide I will show you how you can use the architecture in productions. Just give me a minute. Now I hope it's more presentable to you. Okay. Now, if you see in this slide, this program shows centralized multi-agent orchestrator commonly used in production AI system. If you see here, this is the orchestrator layer, and in step 1, the orchestrator send the initial request to agent A. First request will be sent to agent A. After processing, agent A return the result, which is called state version 1. Now you will think like what is this state version 1? So what we will do, we will store the output we received from each agent in version form. So from agent A we will store as a version 1, from agent B we will store as a version 2, and from agent C we will store as a agent. So, so in step 2 what we will do, we will be using the updated state what we received from agent A. We will send that to the orchestrator and can launch multiple agent like agent B and C in parallel. These agents independently process different tasks and return new state such as version 2 and version 3. Now we will we will have now three state which is stored in orchestrator. One is from agent A, one is from agent B, and one is from agent C. Please don't get confused about why these agents are run parallelly. If it's required, only then it will be run parallelly. If it's not required, then we will first uh, run the agent B, then we will run the agent C. Finally, then we will in step 3, another agent like D may combine, validate, and finalize the output generated by previous agent. So what we will do, we will send all the state which we received from agent A, B, and C to the agent D, and it will validate and generate the final output. So now we will talk about why state storage is important. The orchestrator store every version of the workflow like version 2, version 3, and version so system can track change across agent, share output between agent, resume workflow if failures happen, debug and monitor execution. So maintain memory of the previous step. So this create a reliable and scalable AI workflow where agent can collaborate and while the orchestrator manage the complete process. So if we talk about real world use cases, AI research assistants like enterprise automations, like customer support workflow, AI coding system, multi-step business automation. So the future is AI team. The shift is already happening from single AI model doing one thing to the network of AI agent working together like a high performance team. Here is a quick short summary. AI agents are autonomous systems that act independently on task. Multi-agent system, specialized agent collaborating together, share goal. And now the if we talk about architectures, so centralized, decentralized, and hybrids. So you need to choose based on your requirements. So you can, if you want, you can use this architecture. This is the best. In if I talk about orchestrator layer, here you can use LangGraph. So the future is AI team that plan, build, and decide and adapt together. If someone will ask you some of the questions, so this is how you can answer. I have written on some. So if someone will ask you what is an AI agent, so you can answer like an AI agent is a like a digital employee. You give it a task and it can think and complete the work on its own. So for example, ChatGPT answer questions, coding assistant, helper, developer fix bugs, and support bot reply to the customer query automatically. So basically AI agents are systems that can perform tasks without constant human help. Right now, if someone will ask you about what are multi-agent system, so you can answer. Imagine multi-AI agents working together like a company or team. One agent does the research, another write contents, and another review the work, and one manager agent coordinate everything. This is called a multi-agent system. Instead of one AI trying to do everything, different agent specialize in different jobs. So if someone will ask you why use multi-agent, so using multi-agent make the system faster and smarter. Tasks can run in parallel, which save time. Each agent become an expert in one area, and we can easily scale the system by adding more agent when needed. So multi-agent system improve speed, specialization, and scalability. If someone asks you about architecture, so we can tell him like we have three level of architecture. One is centralized, one is decentralized, and another one is hybrid. In centralized architectures, there is one man controller agents. This controller agents give instruction to all other agent. It is easy to monitor, debug, but everything is controlled by one place. But the main problem is that if the controller fail, the entire system can stop working. This model is commonly used in customer support workflow and simple automation system. Now we will talk about decentralized architecture. In decentralized architecture, there is no single boss. All agents communicate directly with each other and make decision together. This system is highly scalable and fault tolerant because there is no single failure point. However, coordinations become more complex and debugging can be difficult. This architecture is used in robotic, autonomous vehicle and blockchain system. Now, if we talk about hybrid architecture combine both centralized and decentralized system. So some agents are controlled by a supervisor while other work independently. This gives flexibility, scalability, and reliability. But designing and maintaining this type of system is more complex. Large enterprise and advanced AI system commonly use hybrid architecture. Then if someone asks about real world use cases, today many companies already using multi-agents AI system, AI coding assistant using multi-agent to review and generate code. Customer support system use agent to handle tickets automatically. Research agent can huge amount of information quickly, and self-driving car are using decentralized agent to make real-time decision. So that's it in this video. If you need both the slides where I have this PPT, this PDF where I have explained about multiple agents and the uh, question and answer which can be asked related to multi-agent in interviews, I can share with you. You can write comment in video with your email ID. I will share over the email. Thank you. Thank you for taking your time.